Good morning, everyone. Now, this day, we're going to talk about machine learning concepts and classifications and its algorithms. So, this is very essential when you think of algorithms that will solve your proposed project in your soon to be project in your AI lab. So, in our previous lesson, we talked about the problem solving and search algorithms. So we have our examples for uninformed search, such as the BFS and DFS, and of course the UCS or the uniform cost search. We also have the informed search, we have greedy and A-star algorithm. So the key takeaway of our previous lesson was to search the search algorithms, they explore possibilities. However, they also struggle with complexity. So what do we have there is that when we have a specific problem that we want to solve using AI, we have to be able to know what algorithms should be used. Now, for this session, you will be able to define machine learning and its types, explain the distinction between both supervised and unsupervised learning. And I'm pretty sure you have already heard much of this when we talk about AI, but less idea, right? So that is one of our learning outcomes for this morning. Describe the role of classification in machine learning, differentiate common classification algorithms, and apply classification concepts to real world scenarios. So, what is machine learning? So we talked about in our previous lesson that machine learning is under the field of AI because AI is very broad. And it is where systems learn patterns from data and improve performance without being explicitly programmed. So, from the word machine learning, the machine learns from from us. No? So, according to Arthur Samuel in 1959, so this is the field of study that gives computers the ability to learn without being explicitly programmed. So that was according to him. And according to Tom Mitchell, computer program is said to learn from experience with respect to task and performance measure. If its performance at the task, as measured by the performance, improves experience. So of course, if we give tasks to the machine and then it learns through its experience, then that is machine learning, right? Like ChatGPT, we prompt. This is this thing we call prompt engineering. We train it to be smarter and to have a prompt that we wanted to have. Diba? Now, what are the types of machine learning? So one of that is the supervised learning, then unsupervised learning, and the reinforcement learning. Under the supervised learning, we have it's learning from the labeled data. So that means to say that supervised learning is I'm pretty sure in your data science you already thought about supervised learning, right? So you have a data and then you want it to train. So that data or that input is labeled. For example, in an image classification of detecting fruits, there are already images of apples. So apples are labeled, bananas are labeled. We will train apples, bananas, and different kinds of fruits if it given that it's labeled. Okay. Whereas in the supervised and unsupervised learning, it learns from unlabeled data. So it finds hidden patterns. So for example, similar concept, image classification of fruits. So there is no label data. We we want to like train an apple and the machine itself learns what apple looks like. So unsupervised siya, meaning there are no labels. The reinforcement learning naman is they learn by trial and error, receiving rewards or punishment. So we have AlphaGo in robot navigation. So this is very common now And because these robots, they learn from experience, they learn from the mistakes. So that's reinforcement learning, and it's already a high level machine learning. So for the classifications in machine learning, for example, in classification, we predict a discrete label or category from input data. So that's classification, right? We classify different kinds of things. So once again, let's have an example of the image classification. So you want to classify if this is apple, banana, or any kind of fruit or unknown, right? Another example, if it's should we classify this email as spam or not? Okay. Or should we, in the patient, is this disease A or disease B, or is this patient healthy? Or for the image classification of cats, dogs, and other animals or animal classifications, we have that as well. So its difference from the regression analysis is that classification, they predict categories. Regression predicts continuous values. So for example, in regression, um, you're asked to predict the grades of the students or the grades, for example, in board exam. So you want to predict the score of that certain student to the board exam from its grades in his or her academic institution. So those grades, yun yung ating labeled inputs. And then the prediction there is a continuous value on how much score will he or she will be getting in the board exam. So that is this difference from its classification and regression. So to know the classification workflow, we have, of course, first, we have to collect the data. If it's uh, labeled data, then labeled, unlabeled, then we still have to data pre-process it. So in the labeled data, we have to like pre-process it according to its category. But in an unlabeled data, we have to pre-process it, remove the noise it has to it, and then we have to split the data. Should we allot 70% for training or 80% or 60%? But most commonly, 70 is for training, 30 is for testing. Or sometimes it's 70 training, 20 is for testing, and 10 is for uh, validation. Next is the model testing and evaluation. Apologies for that. So we have to test the model actually, right? If the model is giving us a good uh, accuracy, then we can deploy now our model. And for the common classification algorithms, we have the k nearest neighbors. Okay, that's one. We have the decision trees, the naive Bayes, the logistic regression, the support vector machine, and the neural networks. So we are going to divide this common classifications algorithms into two uh, recorded lectures. I'll see you on the next one.